All right, you guys, so today we're gonna go ahead and talk about factoring quadratics. So here you guys should hopefully be able to see the whiteboard. Okay, so on the first slide, it talks about to factor an equation. What we need to do is we need to figure out the number that's gonna add to the middle term and then multiplies to the last term. So you guys should have done a little bit of factoring back in Algebra 1. So some of this should be a little bit of a review, but it's always good to just remind yourself how to factor. So for our first example, we have x squared plus 7x plus 12. So what I need to do is I need to figure out what two numbers are going to multiply to give me 12, but add to give me 7. So whenever I'm factoring and I see just an x squared, I usually start by just getting it ready by writing my two sets of parentheses. And I know I'm going to put an x in each of these because I need to take x times x to give me the x squared. Okay, so that is always going to be kind of how we start. And then from here, we're going to figure out the numbers. So if I think two numbers that multiply to 12, so I could have 12 and 1, I could have 2 and 6, I could have 3 and 4. So usually I think about what multiplies first, and then I try to start adding those together. Well, if I add 12 and 1, that's going to give me 13, so that's not going to work out for us. But I also said 2 and 6 multiply to give me 12. But if I add 2 and 6 together, that's going to give me 8, which isn't 7, so that's not what I want. Then if I take the 3 and the 4, well, 3 times 4 is going to give me 12. And then 3 plus 4 is also going to give me 7. So I can go ahead and know that that's my answer. So I can put in the 3 and the 4. And now it's always good to check, make sure you did this, because factoring is just a little bit of guess and check. So if we FOIL it back out, we should be able to make sure that we truly factored this correctly. So when I say FOIL, remember that's when you multiply your first terms together, your outside, your inside last. So you multiply just everything together. So if I take x times x, I'm going to have x squared. Now 3 times x is going to give me 3x. Then x times 4 gives me 4x. And then 3 times 4 gives me 12. Okay, so I just multiply all those back together. Now if I combine my like terms, I end up with x squared plus 7x plus 12. Which is exactly what I started with, so I did correctly factor this out, okay? So yeah, so basically with factoring, you always think what two numbers multiply to your last term, but add to your middle term. And then once you figure out that, then you can plug them in and check it, okay? Any questions on this first example? All right, let's go ahead and move on to that next slide. So then the next slide, it says factoring a quadratic when our leading coefficient isn't 1. So when the number in front of our x squared isn't 1. So it says when the number is in front of x squared isn't 1, you're just going to focus on what numbers multiply to get your constant. So what numbers multiply to give you that last number, okay? And then we're going to have to guess and check from there. Because from here, we can't use the adding trick. So if there's a number in front of x squared, you no longer think like what two numbers multiply and what two numbers add. Now you're just looking at the multiplication because the adding doesn't work out for us. Okay, so for this second example, so we have 2x squared minus 5x minus 3. So first of all, to get this set up, I'm going to just draw my parentheses. And I now know that in order to get 2x squared, I have to multiply 2x times x. So one set of parentheses, I'm going to have 2x, and one set of parentheses, I'm going to have x. Because that's the only way that I can get 2x squared, is by taking 2x times x. Okay? So now I'm ignoring my middle stuff, and I want to think about what two numbers are going to multiply to give me negative 3. Well, for this, I could have negative 1. Let's see, let me write this over here. I could have -1 and 3. Or I could also have -3 and a +1. And that's going to be it for -3. Those are the only ways that I could multiply and get -3. -1 and 3 or -3 and 1. Okay, so now it's just going to be a matter of guess and check by either trying out these numbers, and you can switch where you have them put in. Okay, so I'm just going to go in order. Let's use the -1 and the 3. So if I put -1 here and then a +3 over here, now I'm going to have to FOIL this back out and see if I get what's up here. So if I take the 2x times x, I have 2x squared. And then -1 times x gives me -x. 2x times 3 is going to give me 6x. And then -1 times 3 gives me -3. So now when I combine my like terms, I end up with 2x squared plus 5x minus 3. So looking at that, it looks close to what I had, but this time my 5x is positive and up here it's negative. So I need it to be negative. So I know that that didn't work out for us. Okay, so let's go ahead. This didn't work, so it's not the -1 over here and the 3 over there. So now we could go ahead and try, we could switch where they are. So I could put it, so I would have 2x, and then I'm going to put the +3 over here with my 2x. So I'd have 2x plus 3. And then over here I'd have x minus 1. So I'm still using a -1 and +3. I just switched where they were. So now if I FOIL this one, I have 2x times x, which is going to give me 2x squared. 3 times x, which gives me plus 3x. 2x times -1, which gives me -2x. And then 2x, or 3 times -1, which would give me -3. So now if I combine these like terms, I end up with 2x squared plus x minus 3. So that one didn't work out for us either. So we can see that we're supposed to be having -5x, but this time I just have a positive x. Okay, so that one didn't work. So we were closer over here, our signs were just opposite. So kind of like a little hint with that, if you're having to have like more x's than like either of your numbers, so if the number is like a bigger number, you know that you're gonna have to take your 2x, your x with the leading coefficient, and multiply it by your larger number. Okay, so like taking the 2x times the 3 gave me a larger chunk of x's, so that's kind of a hint. So over here when we took the 2x times the smaller of the two numbers, that gave us less x's. So if you're trying to shoot for getting more x terms for your middle term, if you put the larger number across from like not in the same set of parentheses as your x with the leading coefficient on it, so the 2x and the 3 having them in opposite set of parentheses, that's going to give me more of my x term, which is what I need. Okay, so that's kind of like a hint. So let's try this. We know that neither of these worked, so it's not going to be that. So let's go ahead, let's do -3 and 1. So if I set my parentheses up, I have 2x and x, and I know I need a large chunk of x's, so I want to have my larger number in a different parenthesis than my one with the 2x. So let's go ahead, let's put the -3 over here and the +1 over here. Okay, so then if I take 2x times x, I'd have 2x squared. Then if I take 1 times x, I'm going to have x. 2x times -3 gives me -6x. And then 1 times -3 is going to give me -3. So now if I combine these, I have 2x squared minus 5x minus 3. Which, that is exactly what I started with. So this time we did it right. So when we factor, we use the -3 and the 1, and it's going to be these factors right here, the 2x plus 1 and then the x minus 3. Okay, so in fact, unfortunately, factoring is just a lot of guess and check. So we are going to go over different methods, so for like how to solve. So today's factoring, so if you don't love this, just hang on. In a couple sections, we're going to do other methods, so you're not always going to have to factor. But it is good to know how to factor, just because it is, for simple equations, it's going to be the quickest way to do it. Like factoring is way quicker than using the whole quadratic formula. Okay, so it's good to know how to do it, but on ones where you have to guess and check a bunch of times, it's not always the easiest ways. Okay, so if you hate this today, just hang on, it'll get better, okay? Questions on this first one? Okay, let's do the second example. So this one, it says I have 3x squared minus 7x plus 2. All right, so if I have 3x squared minus 7x plus 2. Okay, so my number out front is going to be 3, so my number in front of my x squared, so I have 3x squared. So what I need to do when I break this down into my parentheses, the only way I can get a 3 is 3 times 1. So I know I'm going to have 3x over here and just x over here. So that's the only two numbers that are going to multiply and give me 3. Okay? So now I want to think what two numbers are going to multiply together to give me the positive 2. So to multiply and give me positive 2, I could have 2 and 1. But I also could have -2 and -1. Because if I multiply -2 times -1, that's going to give me a positive 2. And if I think this middle term is a -7, so I know somewhere along the way I need to make some negative numbers. So right now, these are both positive, the 3x and the x. So because those are both positives, if I were to plug in just positive numbers into here, there's no way I can get any negative numbers if everything in my factors are positive. Okay, so automatically, I could guess and check, I could put the 2 and the 1 in, but I know that those aren't going to work for us. These are not going to work because that's not going to give us any negative numbers. Okay, so I know we're dealing with the -2 and the -1. And now I want like a larger term in my middle, so that -7 is like a bigger number. So I want to put my bigger number across from my bigger number. So I want to go ahead and put this -2 in this set of parentheses and my -1 in this one. Okay, so let's try that, see if it works out for us. So if I take 3x times x, I get 3x squared. -1 times x is going to give me -x. 3x times -2 gives me -6x. And then -1 times -2 is going to give me positive 2. So now if I combine my like terms, I have 3x squared minus 7x plus 2. Okay, so even though it is guess and check, we could have went through and tried 2 and 1, and then we could have done 1 and 2 if we flipped them, -2 and -1, and then -1 and -2. So it is guess and check, but if you kind of think about it a little bit, you can hopefully narrow it down so you don't always have to check all of them, okay? So if you see like a negative, you know if everything in here is positives, there's no way those numbers will work out and give you a negative number for that -7x that you need, okay? Questions? We're okay? Okay, let's go ahead, let's keep going. So next slide. So this slide, you should be looking at a slide with a graph on it. So it says, relate the factors to zeros of a function. So we know that like the definition of zeros, we talked about this in the first section, those are just our x-intercepts. It's just like a fancy name for them. So zeros and x-intercepts are the exact same thing. So your zeros, the reason they're called zeros, remember, is just because that's where your y value is 0. So when your y value is 0, whatever that number, that's your x-intercept, your zeros, okay? Okay, so our graph, it shows x squared plus 2x minus 8. So we have that graph right there. let's go ahead and factor this equation just for some practice. So if I have x squared plus 2x minus 8. Okay, so if I want to factor this, this one is just an x squared. It doesn't have a number in front of the x squared, so therefore I can think what two numbers multiply to give me negative 8, but are going to add to give me 2. Okay, so I can break this down, and I have x and x, because x times x gives me x squared. And now two numbers that are going to multiply together to give me negative 8. I could have negative 4 and 2. And then if I add those, negative 4 plus 2, well, that's going to give me a negative 2. Well, what if I do negative 2 and positive 4? So if we have negative 2 and positive 4, if I add those together, so negative 2 plus positive 4, that's going to give me a positive 2, which is exactly what I need. So let's go ahead, let's plug in negative 4 and positive 2. Because negative 4 times 2 gives me negative 8, but negative 4, oh, sorry, I put those in backwards. Positive 4 and negative 2. Okay, because positive 4 times negative 2 gives me negative 8, and positive 4 plus negative 2 gives me positive 2. Okay, but let's go ahead, let's FOIL it out to check. So x times x gives me x squared. 4 times x is going to give me 4x. X times negative 2 gives me negative 2x. And then 4 times negative 2 gives me negative 8. Okay, and then if I go ahead and combine my like terms, I'm going to have x squared plus 2x minus 8, which is exactly what I started with. Okay, so remember, if it's just x squared, if there's no number in front of your x squared, you can think what two numbers multiply to give me this last term, but add to give me my middle term, and then plug those numbers and check it and make sure it worked out. Okay, so our factors are x plus 4 and x minus 2. Well, now if I look at this graph, looking at the graph, it shows me that I have zeros, or my x-intercepts are at negative 4 and at 2. Well, if I think negative 4 and 2, those are just opposites of these numbers right here in parentheses. So, because they're just opposites, when you factor, the last step from going from factoring to actually figuring out where your zeros are on a graph is you're going to set this equal to 0. Because if you think this is like y equals x plus 4 times x minus 2, well, we are looking for our zeros, or we're looking for our x-intercepts. Well, at our x-intercept, we know that our y value is going to be 0. So I can go ahead and plug 0 in right here. And now what I can do is I can set each factor equal to 0. So I would have x plus 4 equals 0 and x minus 2 equals 0. So then I would just go ahead and solve these. So subtract over my 4, and I get x equals negative 4. And then over here I can add my 2, and I get x equals positive 2. Which, looking at the graph, that's where those x-intercepts are. They're at 2 and negative 4. So when you factor, it's always just going to be opposite of your factors, or if it says like actually solve for your zeros or solve for your x-intercepts, you just have to do this one last step. So you go from your factors, you set each of them equal to 0, and then you would solve them, and these numbers would be your x-intercepts. Okay? How are you guys doing? Okay. Okay. All right, let's keep trudging along then. Okay, so the next one slide, it talks about the zero product property, which is exactly what we just did. It just says when you factor an equation, set each factor equal to 0 and solve to find your x-intercept. So that's exactly what we just did. Okay. The only thing is there's like a little asterisk, like a little side note for you. It says the equation must be set equal to 0 in order to factor and find the x-intercepts. So if we have something like these examples below, first we have to get everything on one side before we can factor it, okay? So in my first example, this x squared plus x equals 42. So before I can factor, I can't factor that until everything is on the exact same side. Okay, so you want to get it set equal to 0. So I can go ahead and subtract my 42 over. So I have x squared plus x minus 42 is equal to 0. Okay, so once you have it set equal to 0, or all your terms on the same side, you can then factor this. Okay, so if I'm going to factor this, I need to think, so it's just an x squared, so I can put an x and an x in my parentheses. And now I'm thinking, what two numbers are going to multiply to give me negative 42, but add to give me 1? Okay, so if I think about 42, I think that's a multiple of 7. Let's see, so 6 times 7, that gives me positive 42. So I could have negative 7 and positive 6. Because negative 7 times 6 is going to give me negative 42. Oh, but then negative 7 and positive 6, that's going to give me positive 1. So instead I need to go ahead and change my signs. So let's do positive 7 and negative 6. Okay? Because 7 and negative 6, when I multiply those, that gives me negative 42. But when I add them, that gives me the positive 1 that I need. Okay, so you always have to just double check your signs. So even if you think, like, I know that these two numbers, when I multiply them together, gives me that number, always got to double check your signs. Okay, so let's go ahead, let's plug in. So positive 7 and negative 6. Let's FOIL this out just to make sure we did it correctly. So x times x gives me x squared. 7 times x gives me 7x. X times negative 6 is going to give me negative 6x. And then 7 times negative 6 will give me the negative 42. So now when I combine my like terms, I'd have x squared plus x minus 42, which is exactly what I need. Okay, so I did indeed factor that correctly. Okay, so we're actually trying to solve for our x-intercepts. So we're not done yet. So we factored it, but now we need to do this last step. So our factors, we have x plus 7 times x minus 6, and that's set equal to 0. So now I can set each factor equal to 0. So I would have x plus 7 equals 0, and x minus 6 equals 0. And now from here, if I'm going to solve this one first, I can go ahead and subtract my 7. So x equals negative 7. Over here, I can add my 6. So my x is going to equal positive 6. Okay, so it's always just opposite of what's in your factors, which makes sense because if we think about the transformations, how I always told you what was in the parentheses, it was opposite for the shifting left or right. Well, this is why, because your x-intercept, so if it's minus 6, it really has an x-intercept over at positive 6, so it goes over to the right 6. Okay, so that's why with the transformations, it's always opposite for the parentheses, okay? Okay, so our x-intercepts for our first one are negative 7 and 6. How's everyone doing? All right, if you don't have questions, we'll just keep trudging. Okay, so the next one, we have 2x squared is equal to negative 9x plus 5. Okay, so 2x squared is equal to negative 9x plus 5. All right, so first things first, I need to get everything on the same side, so I need to get it set equal to 0. So I can go ahead and subtract over my 2x squared. So I have 0 is equal to negative 2x squared minus 9x plus 5. All right, so now before I factor this, I see that there's a negative with my x squared. You can factor it that way, but I think it just makes it harder. So what I want to do is I'm going to multiply everything by -1 so that I can change all my signs and I can be factoring with a positive x squared, okay? Because for me personally, it's just easier when I have like a positive x squared. So if I multiply everything by -1, I still have 0, but then I'm going to have 2x squared plus 9x minus 5. Yes. Okay, sounds good. Bye, Brayden. Have fun at your ortho. Okay, so now 2x squared plus 9x minus 5. So we're going to factor this. I know because I have the 2x squared that I'm going to put 2x in one and then x in the other one. Okay? And now I want to think what two numbers multiply to give me -5. So I could do -5 and 1. I could do -1 and +5. So basically my options are -5 and +1 or +5 and -1. Okay? So I want quite a few positive numbers for my middle term. So let's go ahead and try to use the one where I'm going to have more positive, like a +5. And because there's a lot of numbers in the middle, I'm going to put that larger number across from my like 2x. So let's put the +5 over here and the -1 over here. Okay, this might not be right. We'll just guess and check to figure it out. But I'm thinking because I need quite a few positives, I want to use my larger number as my positive one. And because there are quite a few of them, there are 9x that I need. Let's try taking the one that has like this leading coefficient, the 2x, times my larger number to hopefully give me quite a few x's that I need. Okay, so if we multiply this out, I have 2x times x, which is 2x squared, -1 times x, which is -x, 2x times 5, which is going to be positive 10x, and then -1 times 5, which is -5. So now if I combine my like terms, I have 2x squared plus 9x minus 5, which is exactly what I had up there, so I did indeed factor that one correctly. Okay? And it's okay if you don't get it on your first time, you can always guess and check, okay? That's the beauty of factoring, you just check it out, and if you did it right, great. If not, you try a different one, okay? Okay. All right, so we now need to go and find our x-intercepts. So we have the factors, we have the 2x minus 1 and the x plus 5. So now to go from my factors, I know that those are set equal to 0. So I can set each of my factors equal to 0. So I'd have 0 equals 2x minus 1 and 0 equals x plus 5. So now, solving this first one, I'm just going to add my 1 over. So I'd have 1 equals 2x, divide by 2, and my x is going to equal 1/2. Then for my other one, I have 0 equals x plus 5. So I can go ahead and subtract my 5. So I have -5 is equal to x. Okay? So I end up finding out for this equation, for the -2x squared minus 9x plus 5, I have 2 x-intercepts, one at 1/2 and one at -5. Okay. All right. Looking at the next slide, we have a word problem now. So it says, Marco hits a golf ball into the air from the 3rd level of a driving range that's 48 feet high. The function, so our golf ball is going to be modeled by the equation -16t squared plus 32t plus 48. And it gives the height in feet of the golf ball t seconds after it's hit into the air. Okay, so we're trying to figure out when the golf ball is going to hit the ground. So to do something like this, so I know if I draw myself a graph. So here's this guy. We learned in the last section that our y-intercept is always our c value. So here's this guy. He hits his golf ball from 48 feet in the air. So he's up all these levels at some Top Golf or wherever he is. But so he's 48 feet from the ground. So he's hitting his golf ball from up here. And then the golf ball is going to come up in the air, but eventually it's going to come all the way down and hit the ground. Okay, so we're trying to figure out when the ball is going to hit the ground. So when the ball hits the ground, that's going to be this point right here. And so it looks like it's going to be an x-intercept. So what I can do is I can factor and then figure out exactly where my x-intercept is, and then that's going to answer the question. Okay, so let's go ahead and do that. Let's go ahead and factor. Okay, so I have negative, so I can set it equal to 0 to start off with. So I have 0 is equal to negative 16t squared plus 32t plus 48. Okay, so instead of trying to factor with putting like a negative 16 in one or making everything like multiplying it and then factoring, so it's like 16t and t on the other side. If you ever have a number in front of your x squared or your t squared or whatever it is, that's going to go nicely into all of these numbers, you can first pull that out. So you can factor it out. So what I'm going to do is I'm going to factor out this negative 16 out of everything in my equation so that I'm going to be dealing with smaller numbers and it's going to be easier to factor. Okay, so if I take negative 16 out of negative 16t squared, I would just be left with t squared. Okay, because negative 16 times t squared gives me negative 16t squared. Okay, now over here, negative 16 times something needs to give me 32t. So I could go ahead and plug in negative 2t because negative 16 times negative 2 is going to give me the positive 32, and then I still need that t. Okay? And then negative 16 is going to go into 48 3 times, and because it's positive, I'm going to need the negative 3, because negative 16 times negative 3 is going to give me positive 48. Okay, so if you ever see a really big number, try to factor it out first, because this is going to be a lot easier to factor than that big equation that we started with, okay? So that's always a way that you can also factor, just by pulling out a number out of all of your terms, okay? You can't just pull it out of some of them, you do need to pull it out of all of them, okay? So it has to come out of all 3 of them. Okay, so now let's go ahead and let's just try to factor this t squared minus 2t minus 3. Well, if I just have t squared, I know that I'm going to have a t in each of these, so t and t. And then I can think what 2 numbers are going to multiply to give me negative 3, but add to give me negative 2. So if I think about that, multiply to give me negative 3, I could have negative 3 and 1, or positive 3 and negative 1. That would be my only options, okay? But I'm going to need a negative 2, so let's see. So if I try negative 3 times 1, that's going to give me negative 3. And negative 3 plus 1, that's going to give me negative 2. Okay, so that should work out for us. So we should have negative 3 and positive 1. Because negative 3 times 1 was the negative 3, and negative 3 plus 1 is the negative 2. But let's go ahead and FOIL it just to check, just to make sure we did do it right. So if I take t times t, that gives me t squared. Negative 3 times t gives me negative 3t. T times 1 is going to give me t. And negative 3 times 1 gives me negative 3. Now if I combine my like terms, I'm going to have t squared minus 2t minus 3, which is what I needed right here. Okay, so if I come over here, I know that my factors truly are t minus 3 and t plus 1. So I have this negative 16 pulled out still. T minus 3 and t plus 1 is equal to 0. Okay? So now, what I can do is actually this number that you pulled out, you can just ignore it. It's not going to change anything because if we were to factor it back in, so say I were to factor it back in, and I'm still set equal to 0, so if I have like negative 16t and then plus 48, if I factored it back in here and set this equal to 0, I can go ahead and subtract my 48. So I'd have negative 16t is equal to negative 48. Then I can divide by negative 16. So I get t is equal to 3. Okay, so if I would have just ignored it and set this factor equal to 0, I would have t minus 3 equals 0. Which then if I add my 3 to the other side, I get t equals 3, which is exactly what I got when I factored it back in. So whatever number you actually pull out, you can just ignore it. It's not going to change anything in terms of solving it. Okay, so you don't have to put this negative 16 back in anywhere. Okay, so what we can do, we can just set our factors equal to 0. So we found when we set t minus 3 equal to 0, we have t equals 3. And then over here, if I take t plus 1 is equal to 0, subtract my 1, I'm going to get t is negative 1. Okay, so I find out that my two x-intercepts are going to be at negative 1 and 3. So here I am at negative 1, here I am at 3. If this graph kept coming back, it would have a negative intercept. It would have the x-intercept at negative 1. Okay, so then the last thing it says I have to answer my question, it says when will the ball hit the ground? Well, even though I have two x-intercepts, we're talking about time. That's why it's in terms of t. Well, I can't ever have negative time. Like my ball can't go backwards into time. It's not going to be at negative 1. So even though this is an x-intercept at negative 1, I know the answer to my question would be the ball's going to hit the ground after 3 seconds. It's going to be this x-intercept over here. Okay? So yeah, so your answer would be after 3 seconds, okay? So anytime you have like a word problem and you solve out and you have two different answers, just question yourself, like, does it make sense to have a negative answer? No, we can't have negative time, so it wouldn't be this one. You can't have negative time, okay? Or like negative distance or something like that, okay? So just think about it. So sometimes it's just gonna be one of your x-intercepts would be the answer. Okay, how are we doing with that one? Okay, okay. All right, then if you go ahead and go to the next slide, this is talking about positive and negative intervals, okay? So we talked about this back in chapter 1, but this is just a little review. So it says find the x-intercepts and then graph to see where the graph is positive and where it's gonna be negative, okay? So let's go ahead and find our x-intercepts. So if I have the equation x squared minus 4x minus 21 is equal to 0. So now this one is just x squared, so I can go ahead and put x in both of my parentheses. And now I'm going to think what two numbers multiply to give me negative 21, but add to give me negative 4. So when I see 21, I automatically think 7 and 3. So in terms of multiplying, I need it to be negative. So if I have negative 7 and positive 3, so negative 7 times positive 3 is going to give me negative 21. And negative 7 plus 3 is going to give me negative 4. So that should be my answer. So I should have negative 7 and a positive 3. Okay, but let's go ahead, let's check, make sure we did it right, just in case. So if I FOIL this, x times x gives me x squared, negative 7 times x gives me negative 7x, x times 3 gives me 3x, and negative 7 times 3 gives me negative 21. Now, if I combine my like terms, I have the negative 7x and the 3x. So I'd have x squared minus 4x minus 21, which is what I started with. So truly, my factors are going to be x minus 7 and x plus 3. So now I can take each of those factors and set them equal to 0. So I would have x minus 7 equals 0 and x plus 3 equals 0. So now from here, I can add my 7. So I end up with x equals 7 and subtract my 3. And I find out my x is going to be negative 3. All right, so now it says that now that I know my x-intercepts, let's go ahead and draw a graph. So I have one at negative 3 and one at 7, okay? So here's one at negative 3, here's one at 7. Now to draw this graph, so it's a positive x squared minus 4x minus 21. Well, because it's positive x squared, it hasn't been reflected or anything, so I know that it's gonna open up. Okay, so my graph is gonna be opening up, and it's gonna come down, and it's gonna go through these points right here. Now, this isn't gonna make a difference. Say I could have this graph, it could come all the way down here. I don't know for sure exactly what's going on. I'm not gonna make you find your vertex or actually plot all your points, because we're just supposed to say where it's positive and negative. So even if our graph goes all the way down for a long ways, and then, or just a short ways, it doesn't matter because it's still gonna go through the points negative 3 and through the point 7, because that's where my x-intercepts are. So then in terms of where it would be positive, this graph would be positive where it's above my x-axis. So it's gonna be above my x-axis from, remember we're always using our x, so from negative infinity to negative 3. And also on this side over here, it's gonna be positive, it's above my x-axis from 7 out to positive infinity. And then my graph would be negative from where it's below the x-axis, so from negative 3 to 7. Okay, so even if my graph goes really, really far down, it still has to come back up and hit that x-intercept at 7. So I don't care where my vertex is, I don't care exactly what it's doing. I just know that no matter what the graph looks like down here, all of this is negative, even if it goes really, really far down or not that far down at all. My negative interval is still just from negative 3 to positive 7. Okay? All right, guys, we are gonna stop there. If you guys have questions, let me know. Otherwise, tomorrow, let me see, I have 2 slides to finish up tomorrow at the beginning of class. So we'll get through those tomorrow. Otherwise, you guys are good to go to your next flex or whatever. And otherwise, stay on and ask me if you have questions. And yeah, have a good day. So.